So we've got the vertical line is moving at a constant rate of 7 units per second. Find the rate of change of the area of the cross-section above the vertical line with respect to time when the vertical line is at a position x equals negative 0.5. So you have this solid here and you've got these squares, and so we're talking about like going, the square here. When you're over here, your square is going to be really teeny tiny because the distance from f of x to g of x is small. Over here, the square would be really big because you have a bigger distance. We're talking about at negative 0.5, so we're looking at whether or not that area of that square is increasing or decreasing at that point. So I treated it like it was the area to the right of the line, which is not a cross-section, which I knew was not a cross-section. And that word cross-section was messing me up, but I did not understand what it was asking at the time. But now that I have seen the solutions, I understand what it is asking. So, yeah, it's
I think I obeyed it.
Yeah, if any of y'all got this right, I would be shocked because
I wrote something down for it.
Yeah.
I wrote stuff down.
Yeah.
I think I wrote a couple words.
I wrote a bunch of stuff down, and it was beautiful, and I thought I had it right, maybe, but it was not right.
Just by seeing that.
I think the question I was trying to answer, I think I did that correctly. It just was not the question that they asked. So, that was a problem. So, what I should have done here is the area of the cross-section should have been this f of x minus g of x squared.
Ain't no way I can do this.
All right. So, if we take the derivative of this, we've got dA dt is going to equal 2 times f of x minus g of x to the first power. You don't have to put that there, but and then we have to multiply by the derivative of f of x minus g of x. So the derivative of f of x, what would it be? F prime of x times dx dt minus g prime of x times dx dt. Yeah. So this is your derivative of the area. So this gives you the rate of change of the area. We want to find the rate of change of the area whenever x equals negative 0.5. So we're finding dA dt such that x equals negative 0.5. Make sure you're writing these down because you're going to turn these in for a FRQ. Great. So that would be 2 f of negative 0.5 minus g of negative 0.5 times f prime of negative 0.5. What do we use for dx dt? Seven. The vertical line is moving at a constant rate of 7 units per second, and that vertical line is an x equals, so it's going to be 7 there. Sorry. So
it makes sense in
I know you guys don't have the calculators anymore because I took them.
I forgot like half of the time that we had calculators. I was sicking because you didn't give us the good ones to find. That's messed up. You gave us the round ones. They were whack.
Well, there's the newer ones. So, I wonder if this is still in my equals. Yes. Y1 is F, Y2 is G. Okay. So 2, Y1. Yes. Yes, they're cleared. Yeah. Yeah. Yeah, I did all of them. You need to write it down because I'm going to give you a bad grade in the FRQ section if you don't turn it in. And we're doing it all together. Ethan, write this down. I've never had a kid try to fail calculus before. You're not failing. You just have to do the things that I'm asking you to do.
You just have to write what she has wrote. Look, if Ethan could type it, he would have been done with calculus months ago.
What question number is that?
Ethan, write it down. I'm going to call your mom. You're not failing.
No, he told us the other day that he was going to try to.
You have a passing grade.
Yeah, really, Jack was there.
It's like the last week.
So Ethan, 62, you get credit.
Yeah.
Cal. You don't get college credit.
You don't get college credit. Well, yeah, but high school credit. Not passed.
You get GPA credit.
It was just an experiment.
Yeah.
I'm calling your mom. I mean it. And your dad.
Just the whole family.
Yeah. So I'm calling his sister. Get the whole family in a conference call. Hi, so Ethan's
Okay.
trying to fail my class.
Like actively trying. I'm trying to ask him to write things down off of the board, and he is not. He is refusing.
All he has to do is copy what I wrote.
Yes, this is all he has to do.
What's your casting? It's Snowball.
Why do you know that? Yeah, how do you just know that? Why do you know that?
Because he put her on Zoom.
He was on. Snowball was on Zoom. I remember Snowball.
Yeah. How do you feel about that? We're going to kidnap Snowball. Copy.
That's incredible.
So sick. Frightening his cat.
All right, so at t equals negative 0.5, x equals the area is decreasing at a rate of 9.2718 for
incredibly unsimplified expression.
I got there, man.
Like,
y'all didn't get this.
behemoth of a.
I mean, I
knew.
I got there, but I made it positive.
I think there are kids out there that will get this,
Yeah, they're nerds.
but I think that it's going to be very few.
Like, they're cards.
And I think, I wonder if this one was on ABBC. So when you take the BC test, you get an AB subscore. So like 3 of the questions overlap. They've put them on both AB and BC. So I wonder if this was also a BC question, and some of the BC kids would be, not that you need to know any of that. They've just, especially if they're in a school where they do AB first semester and BC second, and they've had a lot of review time, they would be ready for it. But I've never seen a question like this ever. So
I got to it's decreasing.
and I have worked out almost all of the FRQs from like the last 20 years. So yes, or I think so. I would not call it the hardest one that I have seen, but I've never seen one like this. So looking at it from here, it's not terribly difficult, but it's really hard to understand what they're asking for.
What did you say? You can't say too much.
Okay, let's look at 4.
Get on him, Logan. Get on him. Sick him.
All right. Okay. Number 4. Ice sculpture melts in such a way that it can be modeled as a cone that maintains conical shape. Oh, this is
What happened to 3?
We did 3 the other day. You're going to have to go back and watch the video or do it yourself, but I would suggest the video because I did every other part of it right except for 2D. We did 3 the other day. All right. Okay. Ice sculpture melts in such a way that it can be modeled as a cone that maintains a conical shape as it decreases in size. The radius of the base of the cone is given by a twice differentiable function, r, where r of t is measured in centimeters and t is measured in days. The table above gives selected values of r prime of t, the rate of change of the radius, over the time interval 0 to 12. Approximate r double prime of 8.5 using the average rate of change of r prime over the interval 7 to 10. Show the computations that lead to your answer and indicate units of measure. So, r double prime of 8.5, you're just going to do slope formula between 7 and 10. So,
oh, no, I'm looking at B.
This is the fundamental theorem of calculus. I was looking at B.
um,
No, it's just a mean average, like value.
this is like it's an average value, but you can just use slope formula. You could use 1 over b minus a integral, but you can just use slope formula here. So you would get, you could stop here if you wanted. I'm going to simplify.
I would stop there.
Yeah, it's fine if you do. I'm going to simplify just so I can check it with answers that are posted a little more easily.
I completely forgot how to do Raymond, so I had no idea.
I did not. I used
That's
formula.
point 2.
I forgot all.
Okay. All right, so I think we've got point 2. Indicate units of measure. What are our units of measure here?
Right, so centimeters per day.
Per day, per day. So that is part A.
I got this one right.
All right, for B, is there a time t from 0 to 3 for which r prime of t equals -6? Justify your answer. Yes, and it is twice. R is twice.
Therefore, it is continuous.
Yeah, R. Well, you gotta say R is twice differentiable.
I didn't say twice.
R, you need to say R prime of T is continuous. All right, you need to be talking about R prime being continuous because R prime is what they're asking about. So if you just said R is continuous, I don't know
I
that.
would say it's like twice differentiable and continuous.
We don't know that R prime is. We know we can take the derivative of R prime because R is twice differentiable. So R prime is differentiable and continuous. It doesn't have to be differentiable for intermediate value theorem. It only has to be continuous. So, so if you said it, it's fine. But if you did not, like, it has to be continuous is what you have to have. I don't know if you have to say R is twice differentiable, therefore, or if you can just state that R prime is continuous, but it does need to be R prime, not R. Therefore, actually, I should say that continuous on 0 less than or equal to T less than or equal to 12. Therefore, by the intermediate value theorem, on this it's fine. They'll take it on the test, I think, too, but I wouldn't risk it. Yeah, and like if you do IVT and your I looks more like a different letter, they're not going to take it. So it's just, whereas if you spell intermediate incorrectly, they're still going to know it's intermediate. So yeah, mean value theorem is not going to work here. It's not because it would be if they had given you the table for R instead of the table for R prime. But since we're looking at the table for R prime and they're asking us about R prime, it's just intermediate value theorem. So by the intermediate value theorem, since I'm going to say R prime of 0, which equals negative 6.1, is less than negative 6, less than negative 5, which equals R prime of 3.
Oh, I did this, but I think I put like the R prime. So I did like R prime of like 0 is less than negative 6 is less than.
It's probably okay with that, I think, especially since the table's there. So, by the intermediate value theorem, since this is the case, there must be at least, I don't think so. At least one time T 0 less than or equal to T less than or equal to 3, 4, which R prime of T equals negative 6.
Actually, I think I might have wrote everything except for less than T. I mean 0 less than T.
You probably need to state the interval somewhere.
I mean, but what's it called? Wouldn't the interval be known because I put R of T for those values?
Maybe. You might can get away with it. I'm not certain. What I generally do with intermediate value theorem is I just try to restate whatever the question was asking. That's my conclusion.
That's what it did for me.
Yeah. So that was a pretty straightforward intermediate value theorem. It's not. The only thing that's a little bit tricky about it is that it is R prime there, which might make you think mean value. Alright. Write Riemann sum. 4 subintervals indicated on the table to approximate this value. This one is a pretty, very straightforward.
Got this one wrong. I could do everything.
Alright, so this would be, we're doing right, so we would have 3 times negative 5.0 plus 4. Distance from 3 to 7 is 4 times negative 4.4 plus 3 times negative 3.8 and then 2 times negative 3.5. And on
Could you
the
put,
mhm.
like 3 times negative 5 plus negative 3.8?
Say that again.
So put 3 times negative 5 plus negative 3.8 and then plus
The other
4.
two.
Yeah.
Yes, you could have. Yes.
Okay. This way you're on the
That seems crazy, but you can do
That's
that.
what I did. Just like,
They have the same width.
yeah.
Yeah, you can do that. My mind would not go there to do that, but you can.
I just did it because it was less direct.
Okay, you can do that. All right, so that there. I'm gonna write down what it is, but I would prefer. I'm using my calculator right now, which is prohibited on this particular section.
I used it.
I would, if I was actually taking the exam, I would stop. I would not simplify this, but yes. 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 It should be a squiggly approximation mark. They do not count off for that if you do that, but it should be a squiggly.
They should grade heavily.
It is not. So I'm cheating whenever I use that calculator. But if I was actually taking the test, I would not simplify this to make it negative 55. So I'm not counting that as B. All right.
You're right.
So
C is in C level. D is in D level. No.
all right.
Roger showed them
You solved it? Yes.
Okay. All right. D. The height of the cone decreases at a rate of 2 centimeters per day. At the time t equals 3 days, the radius is 100 centimeters and the height is 50 centimeters. Find the rate of change of the volume of the cone with respect to time in cubic centimeters per day. At time t equals 3 days, the volume of the cone of radius r is given here. So this is related rates. Here we've done several cone problems like this, but we weren't very good at related rates. So
Was able to do it though.
yeah, I hope so. R over H is 50 over 100. So 100 R equals 50 H. In this case, what do we know is changing? Like what do we know the rate of change of? Height. So we want to change everything. They might have actually made this. They might have actually made this where you can do it without doing what I'm about to do.
Wait, did we have to write that?
That'll give you the rate of change of the radius.
I just wrote
But wouldn't
R
it be
equals 1/2.
R prime?
What?
It'd be R prime of 3, right? Your rate of change of the radius would be R prime of 3.
Yeah.
Correct?
Yeah. That's so sick.
So, I think there's 2 ways you can do it. I think there's 2 ways you can do it. So, like, the way that we did this in class is we would get rid of the R. So, we divide by 100, and R equals H over 2.
Okay, I did that.
Okay? So, volume is going to be 1/3 pi,
Can we write this down?
yes, h over 2 squared times h,
I did that too.
which is going to be, I'm going to write this, pi over 3 times h squared over 4 times h. So your volume is going to be pi over 12 times h cubed. So if I take the derivative, I get pi over 4 h squared dh dt. And then we want rate of change of the volume, so that's dv dt whenever t equals 3, which is going to be pi over 4 times the height squared. Height is 50, and dh dt decreases at a rate of 2, so you need to put a negative 2 right there.
I really hope I put that.
Yeah, I
Now
know.
that I'm thinking back, I'm just like, did I?
Did I put the negative? I know. So you should probably leave it here. Let's simplify it just so that we can check the answers a little more easily, but you should probably stop at this point. 550 squared is going to be 2.
I think I did
2500, right?
Well, 50 squared is about 250, and 1050 is 500. So 50 is 25. Come on, man, you got it.
Yeah.
Yes.
All right, and then I would reduce this 2 right here and make this 2, and so it's going to be half of that, so it's going to be negative 1250 pi.
Wait,
T is time, but that's not actually a variable in this equation. But at t equals 3, it tells us height is 50, so we plug in h for 50. So this should work, even though, I hope everybody's getting this down.
I've got it. Wait, was that not the
This is still part D, but I just want to work this out real quick to see if I get the same answer. I'm going to keep this 1/3 pi out front. It'd be r squared times dh dt plus h times 2r dr dt. And so radius is 100. dh dt is negative 2. H is 50
That's 2,000. 2,050.
times 2 times 100 times the RDT is negative 5.
So what's 100
All right. So I'm just going to use the calculator.
Well,
Let's
100
see.
times 100 is 10,000. So that's negative 20,000.
It's already wrong.
Plus
100 times 100 is 10,000.
It is.
100 times 100 is 10,000.
It's so quick. No more.
100 times 100 is 10,000. Yes, it is.
I barely caught that in 100 times 100.
Do it. Do it right now.
He's right. Thomas is right.
I'm right. It is 10,000. 100 times 100 is 10,000.
How did that work?
Nerd.
Oh, 1,000 has 3 zeros, not 4.
Negative.
All right, let's
So
see.
that's negative
Let's see.
20,000.
I don't think these are going to be the same, are they?
Negative 20,000.
This is
These are different.
Dude, I straight up thought 100 times 100.
Plus
100.
200 times 5 is 50,000.
Quick math, what is it?
Well, it's negative 50,000, see?
No, all that.
Oh, that's
Well, 70.
3 times negative 70,000, which is roughly 2.5.
Yeah.
Wow, that's
Wouldn't it be
a lot.
Yeah, you're getting
Because 7
negative 70,000
divided by 3 is 2.5.
over 3. So it's like it's not the same answer.
I'm like, what are you on about?
So
Uh-oh, this high.
let's
The answer key.
let's see which one is.
Oh, for instance, Steve.
I'm gonna look at. He posts too much. Okay, this one's looking for. Let's see what.
Bobby's still in it. Bobby's in it. He got signed up for it.
I never got placed on it. I actually did try.
All right, so we got that part right.
Oh, why is it set 3 attachments?
All right, negative 51. We got that.
He never got taken off.
I didn't put units on C. I don't know if it would count. Let's see. D.
Wow.
I have 71,000.
He did it the second way. So okay, so the solutions that were posted.
Which one is
Jack, he's never going to close it.
Neither.
We're still getting pushback.
Oh, wait. One is copyright.
I think the second one is the correct way to do it
I'm so sick.
because
So we're just super.
we don't know that the cone like retains the same dimension. Like if you have a tank that's draining, you know for sure that the bigger cone is similar to the smaller cone.
I am beyond sick. I can guarantee you I did not get that.
I'm hoping, I feel like this is going to be a very common wrong solution. So I'm hoping maybe there's something there they'll still give you some credit for, but I don't think it's right.
I'm running out of.
So here's the actual, here's what you should actually do.
So we could erase basically everything we just read.
Yeah, or just mark it out and write this.
Oh my.
That first part of D that we did, it needs to be that second way that I did it.
Is R still equal interim 2?
I have to write down.
Or is that just
No, it does not. The second part, that's what we should have for D.
Not pushing B at all.
This is closer to what I think that's what.
Yeah, Noah somehow got it right.
I feel like, because I took the area equation and I took the derivative and I was like, numbers, and I put the numbers in.
You definitely did not.
Ethan, how much of this have you written down?
Yes. Yep, this part right here is what you need to have for D.
I just know I got it wrong.
Or volume equation, not area, but volume.
Yeah. So, no, I did that.
Yeah.
I just don't know if I put the -2 or not.
Yeah, with the DHT and the DRDT.
Yeah.
I don't know that you would get any credit if you don't have DHT and DRDT.
I had both. I wrote them somewhere in the exam.
Is that an 8 or a 3? It says, oh, it's not 135.
Yes, and you can actually stop here. I was just simplifying further to make sure that so that I could check my answers more easily.
According to statistical probability, the likeliness we got the rest of it right. You're right. Because we've been losing a lot of things. Quite a few L's.
No, I don't take any L's.
I'll just take them because he is the L.
What? W's only. Because, I mean, I ain't taking this class to get credit. I like That's not my goal. My goal is to work. And learn I have. That's right. I've learned to be humble. Nope.
Thomas has learned that math is hard.
And I know how to take derivatives, and I can do integrals really good. And I can do high and low over low D high. Wait, no.
And graphs, you're good at
Low D high times, wait. Low D high
Minus.
times high D low over high squared.
It's low high D plus high low.
low squared.
Low squared. Are the things? Yes, they are. Okay. Look, I got it. Wait, did I get it right?
No.
Oh, I didn't get it right.
All right, let's look at 5.
Really made a scene just to
Okay. They give us this differential equation. They tell us that F is the particular solution. We'll do those in a second. Let's not mess with them right now. All right, so let F be the particular solution to the differential equation with the initial condition f of 1 equals 2. The function is defined for all real numbers. A portion of the slope field for the differential equation is given below. Sketch the solution curve through the point 1, 2. So they've put the point right there. It won't let me write on this, but you basically just need to draw in like a sine curve sort of
No, you just
thing
follow
here.
the line.
Yeah, just follow the lines. Yes. You can write. You can draw on your paper. I cannot. It will not let me write on this right here. Actually, just put it with your. Yeah, just put it on the paper. You can turn it in with it. Actually, I can't. Actually, I can do this because I can do screen clipping here. There we go. Oh, that did not go where I wanted it to go.
The bubble use
statistical probability. That we got the rest of it right.
anomaly.
Oh. Sorry. It's not moving. It's not moving like I want it to.
You just hold left click and scroll with
I'm trying.
Is it not working?
I don't know why it's not working. It usually does. But there, we finally got it where it needs to be. Alright, and so you're just going to draw in something. Oh, that's too big. Something. Something like that.
He just
Like unzip it.
yes.
Okay. Alright, that's A. Hopefully you guys got that one. I hope. Yeah, it's probably just a one pointer, but I don't think
Should have
so.
started at like 6.
Yeah. Yeah. All right. B. Write an equation for the line tangent to the solution curve. In part A, at the point 1, 2, use the equation to approximate f of point 8. So the derivative, dy dx at xy equals 1, 2 is going to be 1/2 sine of pi over 2 times x, which is just 1, square root of y plus 7. Technically, you can leave it like this, but it's going to be hard to write that tangent line if you do. So I would actually figure out what this is. So you got 1/2. What's sine of pi over 2?
I left
1.
it like that for a moment.
And square root of 9, which is 3. So we got 3/2 for this. All right, that is your slope. So your tangent line would be y equals 3/2 times x minus 1 plus 2. And then f of 0.8 would be approximately 3/2 times 0.8 minus 1 plus 2. So that would be your estimate. Now, I'm going to figure out what that is. It's 1.7. I would not do that on the actual exam. I would stop here, but for being able to check a little more easily, we'll do that. So feel pretty good about A. You guys got B? Okay, good. They're pretty straightforward problems. C says, it is known that f double prime of x is greater than 0 for -1 to 1. Is the approximation found in part B an overestimate or an underestimate for f of 0.8? Give a reason for your answer. So, what does it tell us since f double prime of x is greater than 0, what does that tell us about f? F is concave up. Second derivative is concavity for -1 less than or equal to x less than or equal to 1. So if we're looking at concave up, where's the tangent line going to be? Underneath. So f is concave up on this interval. Therefore, the estimate in part B is an underestimate. That is probably just a single point question as well. I think A is probably just 1 point. C is probably just 1 point. I bet B is 2 points. A point for a tangent line and a point for the estimate. And then D is probably going to be 5 points because it's solving a differential equation with trig. Ugh. Alright, so D is going to ask us to find the particular solution here. So we're just solving this differential equation. Yes. Okay, so we would need to multiply by dx and divide by that square root of y plus 7. So we're going to get dy over square root of y plus 7 equals 1/2 sine of pi over 2x dx. Okay, we are right here. We will integrate both sides. Alright, so over here, this is a u du substitution. It's not going to be natural log because you have a square root in the bottom. So the u is y plus 7. The du would just be dy. So this is the integral of u to the negative 1/2 du. And so when you integrate u to the negative 1/2, you're going to have u to the positive 1/2, and then you'll divide out front by the 1/2, and you'll get a 2 right there. You could possibly still, if you do not separate them, or if you don't separate them, if you still have x's or y's, you can't get any points on the whole problem. But if you've got them separated, especially correctly, a lot of times sometimes the integration point's all together, and sometimes it's 2 points, like one for the left side and one for the right side. And then oops, I made that a x. Sometimes, if you only integrate like one side correctly, you could still get the plus c and plug it in the initial point correct, but you won't get the y at the end, I think is how it will work. So I think you could still get up to like 3 points if you don't integrate this left side correctly. Sorry. Over here, we also have a u du. So on this side, u equals pi over 2x, so du equals pi over 2 dx. So we need a pi to be added right here, which means we got to put a 1 over pi out here. So that is going to give us, we'll get 1 over pi. The integral of sine is negative cosine, so that'll make that negative cosine of pi over 2x plus c. And then we need to plug in our initial condition, which is 1, 2. So we'll have 2, and we'll go over to this side. 2 square root of 2 plus 7 equals negative 1 over pi cosine of pi over 2 times 1 plus, plus c's right there. So we were going to have 6 on that left-hand side equals negative 1 over pi. Cosine of pi over 2, what is that? It's 0 plus c. So we just end up with 6 for c. And then we've got 2 square root of y plus 7 equals negative 1 over pi cosine of pi over 2x plus 6. So if you get to this point, I think you probably got 4 of the 5 points for this. And so then you would solve this for y. So when you do that, you'd have to divide by 2, which I'd make it like multiplying by 1/2. So you got square root of y plus 7 equals negative 1 over 2 pi cosine of pi over 2x plus 3. You would square both sides. That would get rid of your square root. And then when you would need to subtract 7 from the end. So you should end up with y equals negative 1 over 2 pi cosine of pi over 2x plus 3 squared minus 7. I should probably check this one before we move on. We'll freeze it so I can check to make sure that is right. Let's see. 3/2. Concave up. That's fine. Right. Oh yeah, mine looks just like his. Yeah. Yep, that should be right. Just to let you guys know I've not missed anything yet except for 2D. Alright, we okay to go to the next one? Alright, particle question. Particle P moves along the x-axis such that for time t is greater than 0, its position is given like this. Q is given like this. They give you velocity of Q. So you got to make sure you keep that straight. And they give you a position. So, find Vp of t, the velocity of particle P at time t. So, this one, we're on 6a. You're just taking the derivative of that xp of t. So, xp of t is 6 minus 4e to the negative t. One thing you need to be careful about here, like you need to call this xp prime of t and say that it equals vp of t. And you're just going to have the derivative of 6 is going to be 0. The derivative of 4e to the negative t, it's going to be 4e to the negative t. You'll have that negative out front, but then you'll have to multiply by the derivative of the negative t, which will make it positive. So it'll just be 4e to the negative t. That's it for A. That's all you have to do. For B, we're supposed to find the acceleration of Q at time t and find all times t for t is greater than 0 when the speed of the particle Q is decreasing, and justify your answer. So they tell us that VQ of t is 1 over t squared, which I'm going to write as t to the negative 2 power. And so V sub q prime of t gives us A sub q of t, which is going to be negative 2t to the negative 3. Or we could write that as negative 2 over t cubed. So what we need to do So asking about speed decreasing. What has to be true for our speed to be decreasing? We need different signs. Same would be increasing. Acceleration and velocity, we have to look at both of them. So acceleration being negative is only going to tell us that we're decreasing if our velocity is positive. If our velocity is negative, then the acceleration would have to be positive. So you want different signs for those. So no, speed does not have direction, so it's not positive or negative. Right, speed would be like the absolute value of velocity. So it's related to velocity, but it's yes, yes. So what you want to do here? It tells you only have to look for t is greater than 0, and so here. Actually, we don't really need to draw this. We don't really need to draw this because for t greater than 0, what can you tell me about the velocity? If I've got 1 over t squared, it's positive. Actually, it's positive all the time, right? Yeah, it's undefined at 0, but everywhere else it's positive all the time. And then here for t is greater than 0, what can you tell me about the acceleration? It's always negative. Therefore, the speed of the particle is decreasing for t is greater than 0.
Could you say, whenever t is positive?
I think that would be okay. Yeah. Did some of you guys get that one, you think, on the exam?
Yeah.
Okay. All right. Now they want the position of particle Q at time t. So what they're asking for is just the position equation for Q. So we've got V Q of t equals, I'm going to write it as t to the negative 2, 1 over t squared. How do we get from that velocity to the position? We will integrate. So we will get, we're going to call that y, that's a q, sorry. YQ of t equals, this is going to be t to the negative 1. Divide out front by that negative 1, you'll get negative t to the negative 1. What else do I need? Plus c. Uh-oh. All right, so in order to have this equation, we don't need that c to still be there. So they tell us that the position of particle Q is YQ of 1 equals 2. So we can plug that in. We'll plug in a 2 here, and we'll have here negative 1 to the negative 1 power plus c. Negative 1 to the negative 1 is just going to be 1. So we'll get 2 equals negative 1 plus c. So we get 3 for our c. So YQ of t is going to equal negative t to the negative 1 plus 3. Let's see.
Is there a question?
Yes.
I did not get that one.
That one probably.
How many FRQs do you need to get a 3 probably?
It just depends on what your multiple choice is. If you can get about half overall, there's 108 points. So if you get, I mean, if you got all 54 multiple choice right and none of the FRQs right, then you could probably still pass. But
You got like 2 or 3 of the FRQs,
like 2 or 3 points, or 2 or 3 of the whole questions, you're in pretty good shape if you have a decent multiple choice. If that's the case. All right. And then part D, we've got as t approaches infinity, which particle will eventually be further from the origin? Give a reason for your answer. So what you want to do here is you want to do the limit as t approaches infinity of the 2 different position equations. So like for q, we'd have y q of t, which I'm going to write limit as x. Not x, t, sorry. As t approaches infinity. T approaches infinity of negative 1 over t plus 3. What do you get as t approaches infinity there? 3. 3. Then we'll also do limit as t approaches infinity of the position formula for xp of t, which is going to be the limit as t approaches infinity of, I'm going to write this way, 6 minus 4 over e to the t. So those negative exponents send them back down to the bottom. What's this going to give you?
Oh, that's what you
6. So as t approaches infinity, particle p will be further away from the origin.
I started tweaking because I didn't know, like, if you move the e down, if you had to move something from that position.
You do not.
Wait, is this the only explanation we could have?
I got it right, though. Yes, sir. We're 1 for.
The answer to that is probably no most of the time, but it's got to be along these lines of sorts.
Yeah, we at least got 1.
I don't really.
So,
I think I got
I got both.
so I'll be honest. Other than 2D, I don't think this was that hard of a test. Now I realize we didn't do a great job on related rates, and that related rates was a little bit different because it was a cone problem. We do a lot of cone problems, but it was different than the cone problems we have done. So, so that was a little bit tricky, but I don't really think this was that hard of a test. Yes, so if you are done, make sure your name is on it, put it in the basket for me. If you have not done 1 through 3, then you need to do 1 through 3.
You did 1 through 3? Sicko. When you pull nobody. No.
If you've not done 1 through 3, do that for me.